Hello again, everybody. It is 3 p.m. That means it's time for the STEAM train. This is going to be based on kids in grades 3rd through 5th. We're going to have a STEAM lesson today based on engineering. We're going to go all the way back to some architecture from the Greeks. Greek architecture is really famous for having one type of structure in it, a column. If you've never seen one, you might have seen those really old buildings with pillars up and down, and they hold the building upright. You even see some of it today in buildings like the White House or city halls. They use the same type of columns. But theirs weren't just decorative. Theirs actually were the only things holding up their buildings. So you see we have a big heavy piece of stone or rock on top, and we have these pillars in the middle. There was actually a lot of design and engineering that went into these pillars. If you don't know what an engineer is yet, it's somebody who helps design and solve problems. So a really cool city will have a lot of engineers that are there helping and building the city to make it even stronger. So we're going to do some experiments to see if we can make our own pillars and what type of pillars are going to be the strongest. And then we're going to learn a little bit about the history of these types of buildings and how we can make ours look pretty cool and even make our own out of some really easy household supplies. Before I go any further, I just want to say that I am Dorian with New Minds, and stay tuned for all of our awesome classes we're going to do throughout the rest of this week. The only supplies you're going to need to make your own pillars are actually really simple. We're going to turn a kind of weak material into something really strong. All you need is a little bit of tape. You can use staples if you don't have tape on hand, that'll be fine. Or paper. And that's all we're going to need. If you try and have paper by itself, it's actually not going to be very strong. If I set it down, it won't even stand up by itself. It's going to fall over. But there's some things we can do to make paper even stronger and even hold up way more weight than we could. The first thing we need to do is take this and figure out what shape we want to make it. Most of the Greek pillars were actually rounded, which is pretty awesome. But we need to test out what the other shapes will do when they hold up structures. So the first thing I'm going to do is I'm going to fold this into 3 pieces and make it into a triangle shape. So all I'm going to do is fold it in thirds until I have a nice triangle shape. Then unfold it, make it form into a triangle. And now I have my first pillar I'm going to test. I'm going to put a little piece of tape so it'll stay together and won't fall apart. And we'll have the first part of our experiment. We're going to test all sorts of different shapes today and see what works best and what doesn't work. Well, that's part of being an engineer, is trying things, and even though you might think they might not work, seeing where they end up. So I'm going to have my triangular pillar, just made out of regular paper. And I'm going to start my first test. I'm going to use books for my test to see how many books each pillar can hold up. And we're going to keep track. So this is once again a 3-sided. It's a pillar, triangle, paper, really simple supplies. I'm going to grab some books so we can see what will hold up. I'm going to put one book underneath it so it's nice and level. And I'm going to set these on gently when you're doing this experiment. You don't want to knock the pillar over by pushing it. You're just going to set it on top nice and even and see if it holds up. This is pretty balanced, and if we let go, the paper's holding up one book, which is pretty good. All it was is a piece of paper that couldn't stand by itself, and now it's holding up one book. Let's see if we can make it hold a little bit more. I've got some magazines. I'm going to try stacking those next. Now it's holding 2, and then it kind of collapsed. So triangle, not quite our strongest shape. You see it got a little bent up and broken. So let's try if we add more sides. Maybe we make something like a square. It might hold up a little better. I'm just going to do the same thing. I'm going to move my books out of the way. We're going to make a 4-sided shape. So I'm going to fold it into 4 even sections. You can just fold it in half twice and then bend it back into the right shape. You don't have to test these with the same shapes I am. If you really want to make a pentagon, you can do that. If you really want to make something with 10 sides, you can do that. But make sure you write down your results of your experiment, because that's what makes a good scientist, is writing everything you make down. I'm going to fold it back, and now I have my square pillar. I'm going to tape the edge just like the triangles. Hello, Malcolm. I hope you're doing well. And now I'll have a square pillar. These still don't quite look like the Greek pillars, so we'll see what a circle pillar does right after this. We'll see if it holds up a little better. I'm going to put my same thing bottom. Try my square pillar now and see if it can hold up the first book. Ooh, not quite. So this actually isn't as strong as the triangle. There's a couple of reasons why this might happen. If you look at the triangle, you notice all the sides are closer together. It's going to be a much pointier shape and everything is more compact. With the square, there's a lot of room for things to bend and shake, and all the sides are kind of loose. You can turn it into different shapes really easily. This triangle wants to keep its shape no matter where I move it. So that might be a reason that this is stronger and this isn't. But next thing I'm going to do is make a circle pillar, just like the Greeks used to have, and see how this works out. All I'm going to do is take a piece of paper, and I'm going to go ahead and roll it up. Going around the world to the Parthenon would be an awesome idea. And the same thing, once I have my circle pillar I'm going to test, I'm just going to put a piece of tape on it. We're going to test it out. Let me go ahead and grab some books. So I have my pillar. I want to make sure it's nice and balanced. I'm going to put my first book on. There we go. I'm going to put a magazine on next, and we're going to see how heavy this can go. Looking good so far. Put another magazine on. Still holding up. And I'm going to put another magazine on. And it's still holding up. We're going to keep adding more books and see how high this can go. But you notice how much stronger these circle pillars are. The reason is it's a very strong shape. It has so many edges and sides that it's completely smooth around. It has 365 degrees in it. So it's going to keep pushing in against itself, and it's going to want to stay in a circle shape no matter what. The same with the triangle. It's really compact and it wants to push. This circle pillar is going to do the same thing. So I'm going to keep adding books. We're going to see how high it can go because I'm curious and I want to find out. So I'm going to do a science experiment. I'm going to get some bigger books and see how high we can make the stack. Let's see if we can get it to go all the way off the camera. So we'll put this one on top. This is a pretty big, heavy book. Still holding up. We have another big, heavy book. Let's see how it does. Ooh, it's a little wobbly. But it's still holding. We're doing good. We might be able to do a few more books. Have a smaller one. Looking good. Aw, man. So it was able to hold up 5 or 6 books, and it did a pretty good job. And it's actually still intact. All that happened was a little bit of the pillar bent. But this pillar doesn't look as pretty as the Greek ones did. We're going to talk a little bit about that. I'm going to pick up my books first for a second, but feel free to try this experiment with big tubes. Maybe you can have a bunch like a Colosseum. You can have a circle of tubes trying to hold up your books. You can even make multiple pillars like this and see how many 2 can hold up. Make sure they're the same size. These are a little bit different. I guess I use a different size paper. Not sure. But make sure all your pillars are the same height and level. You can do this experiment using 8, 10, 12 pillars and make your own Greek building out of books and see how many you can hold. I'm going to pick up my books and I'll be right back. Give me 6 seconds. 5, 4, 3, 2, 1. And I'm back. So, the Greeks actually used 3 different types of columns in their architecture. They all have fancy names, but some of them are prettier than others and some are stronger than others. The three types, I did a little rough drawing of them, but the first one is called a Doric pillar. These are kind of the boring ones. If you look, there's no details on them. It's just a regular pillar. They might have some ridges maybe, and then they have a nice flat piece on top. These are always on the outside layer of the building where it's the heaviest. This is because you want to have the strongest foundation, and these weren't meant to be pretty. They were just meant to hold up the building. But as you go further in and further in, we want to make the building much prettier. The next kind was called Ionic pillars. Most of the pillar was pretty much the same, but the top had some decoration on it. They were pretty cool. They're the ones that you probably recognize with the swirls on the corners and then the carvings in the middle. These were made to be a little bit strong and a little bit pretty. They were kind of in the middle. These are more common in the second layer or sometimes on the outside on like just a middle part where it wasn't too strong. The corners were almost always Doric pillars. And the last one is called Corinthian. These are the most decorative ones. They weren't super strong, but they were still rounded. But they're the ones who had the really tall things. Maybe they have carvings of faces. Maybe they have carvings of statues, people on horses, all sorts of things. And these are the really pretty pillars. So there's a couple things you can do with this experiment. The first thing you can do is once you have a paper pillar, you can decorate it. You can make it look pretty. You don't just have to have a white tube. You can add on to it and make it look pretty. So I'm going to add some designs on mine to make it a little bit nicer looking pillar. We'll see if we can do another test and see if we can make this one last a little longer. You can do the same thing and maybe a little easier with your triangle pillars or with your square pillars because you have different sides to decorate. And if you were living in this time, you wouldn't want a house just made out of big plain pillars. You want to make it look really pretty. So I'm going to decorate the bottom of mine. I'm going to add a snake drawing on it because I think that'd be pretty cool to have for my house. Draw a little snake. There's a little tongue sticking out. So you can kind of see it. I added the snake drawing to the bottom. He's going to wrap around the pillar. And on the top, I'm going to add some more decoration. And this is a really easy experiment, and it only takes 2 supplies. Tape and white paper. I'm going to add some X's on the top because I think it's going to make a cool pattern. And I might even add some squiggles or some lines down the side of my pillar. Something like this. I'm going to have this pillar be in the center of my building, but I'm going to show you the next step. Because using one pillar, it can really only sit in the middle. But if you use 5 pillars or 4 pillars, you can put them all around the building in different ways and see what stands up stronger. So I'm going to make a few more pillars and we're going to do some different experiments. Just like earlier, I'm going to make sure they're the same size, so I want to roll it the same way. I don't want to turn it this way because now my pillars are going to be different heights. So I'm going to turn it the long way. I'm going to roll it up and start to make my own Greek building. They had to do this because they didn't have the same construction techniques we did. They had some sort of cranes that they could use using levers and pulleys. They were able to lift up big heavy stuff, but they didn't have things like drills or concrete. So every piece was still separate. That's why you see some of the buildings are still standing today, because they were extremely strong materials. Big blocks of stone, big different minerals. Some of them were made out of marble, and they were very, very heavy, and they were just stacked like blocks. So if they fall down or over, they wouldn't really break, but it'd be hard to put it back up. So all the pieces are usually still there somewhere, or hidden under the ground. So I have 2 pillars. I think I'm going to make 4 for my next experiment. So I'm going to keep rolling my pillars. I want to make them look really nice. If they have dents in them, they won't be as strong. Just imagine if you had a Greek pillar and you cut a little chunk out of it, it wouldn't be as strong as if you made it nice and sturdy and straight. And pillars aren't just an old way of building. We still use them all over the place today. I'm sure you've looked around in a building, you've seen like a pole in the middle of the room, maybe in a big store, you see poles holding up the ceiling. All these different things are going to be around today. That's the really cool thing about Greek architecture, is we still use some of it. Just like I mentioned, the White House building and the Capitol in Austin and all sorts of different Capitol buildings. We use the same type of Greek architecture in it. So I have 3 pillars so far. I'm going to make 1 more, and then we're going to do another book experiment to see how many we can hold with 4 pillars. Make sure they're all the same size, once again. And you can decorate all of them before you do this. Maybe you can make something really awesome and make a really colorful book stack. Maybe you have a bunch of really nice books you like that are really pretty. You can make your own building with it. Just make sure you ask your parents, depending on what books you're allowed to use. You don't want to drop a big dictionary on the floor and lose it. So I'm going to put this book down at the bottom. I have my 4 pillars all ready to go, and I'm going to start my tower experiment. So I'll put these 4 down. And the first book is the most important one. You want to make sure it's touching all the pillars and has a nice place to rest. Now I'm going to start my experiment. So we're at 1 book. I'm going to try and stack all the same books we had earlier on top. That's 2. Looks pretty good so far. I'm going to start grabbing the big books first. Put a 3rd one up here. It's looking good. A 4th one. Still looking pretty good. Even though this is a much stronger building, make sure you're still gentle when you put them on top, because if you knock them over, they're going to collapse. So you're going to put it straight down on top. You might need a parent to help you if it gets really tall like mine is. I'm going to put another book on top. And this is holding up way more big books. I'm going to see if I can get another really big book on top. And the really cool thing is that this is all just held up with 4 pieces of paper. Probably when you started today, you couldn't think that 4 pieces of paper would hold up this many books. I'm going to tilt the camera up so we can keep stacking and see how high we can go. But all of this is just paper. If I try to hold my arm out really far away from my body, I guess you can't see it because of the books. If I hold my arm out really far away and I try to hold all these books, I don't know if I'd be able to hold it. But all of this paper is actually just going to hold this up, no problem. It's not even moving. I can leave it up here for as long as I want. It's going to stay balanced. I'm going to tilt the camera and see how high we can get our stack to go. I'm going to keep stacking books until either I run out or this falls over. Looking good so far. I have a couple magazines I'm going to put on top. It's still holding up really nicely. I have a couple more books I'm going to put on top. I have a couple more books I'm going to put on top. And we can keep going. All of this is held up just by paper. Imagine how much weight you can hold up with 1 super strong stone pillar. It's going to keep happening, and it's going to stay up for a really long time. That's why these are so strong. Even though I used a really weak material, paper is something we can all just tear with our hands. But it can be really strong if you use it in the right way. And that's what a job of an engineer does. I'm going to see if I can keep stacking books and see how high I can go on our paper pillars. And if you missed it or you're just now tuning in, don't forget these videos will be uploaded right after we finish them, so you can go back and start from the beginning and see what we talked about with Greek architecture, the types of columns and pillars, and seeing what else you can stack. I'm actually running out of books, so I'm going to see if I can keep stacking. We're kind of going off the camera. But we have a whole bunch of books just on paper. So if we keep going up and up and up and up and up and up and up, it's still going to keep holding and keep holding. I'm about to touch my ceiling, so I'm going to see if I can keep adding things. Oh, no. And there it goes. So it can't hold it forever, but we were able to hold about 25 books on top of our tower. And that's the experiment. If you have 8 pillars, do you think you can hold it much longer? If you have 4 pillars, do you think it's going to hold shorter? And what shape is going to be the best? And our pillars, if you look, they just kind of crunched a little bit because they still want to keep its circle shape. There's still a hole in the middle. They didn't completely flatten. So it's kind of cool to see how it works out. So show us your towers and how many books you can stack on top. Maybe you can put a weight on top if you ask your parents and you're careful with it. But see what you can stack and see if you can use some of the Greek architecture. The final count of books, in case you're wondering, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. We have 29 books that were just held up by 4 pieces of paper. Thank you guys for tuning in to the 3-5 Steam Train. I hope you guys enjoy the next segment that comes on at 4. And have a wonderful day. And thank you for tuning in with New Minds.